Okay, this tutorial is on solving acceleration equations. I won't say equations, I'll say problems. So one of the fundamentals that you're going to need to be able to do in order to solve any kind of acceleration problems is remember the difference between velocity and acceleration. One of the biggest reasons why students get these types of problems wrong is that these two things are interchanged. So velocity has units of meters per second. Velocity is its own thing, that's speed. That's speed and direction. Acceleration is not talking about your speed, but it's talking about how it's meters per second or meters per second squared. And this is talking about a change in speed and direction. Alright, so velocity, an average velocity, V average equals a displacement over a time, but A average equals a change in velocity over time. Alright, so this change in velocity means you will have a final and an initial velocity either described or implied by your problem. Alright, and then on the other hand, for the average velocity, you will be given one velocity only. No change will be given or implied in the problem. Alright, so if you can distinguish between those, then it's just a matter of remembering how to do algebra and being comfortable with the fact that in physics we use a lot of letters, and letters can mean two different things. So if we're talking specifically about the acceleration equation, A average equals delta V over delta T, then there are three elements to this. There is the acceleration. Alright, there is the change in velocity. Alright, remember a change in velocity equals V final minus V initial. You can do that in your head, or you can do that using this equation. And then you have a change in time, a passage of time. Alright, so those are the things. So basically, when you're working with this acceleration equation, there are three possibilities. Possibility one, question gives delta t and delta v. In this case, you just divide delta v divided by delta t, and of course the units of this are going to be meters per second squared, or meters per second per second. Okay, the second possibility for this equation would be question gives A and delta t. In this case, you're going to have to do some algebra to it. All right, and before I even plug in numbers, I can actually do the algebra now. And so what I'm going to do is, if the question gives A and delta t, then I need to solve for delta v. All right, so delta t, I multiply delta t over 1 by both sides, and delta t divided by delta t, they're the same thing, so it's just 1. And then so we get the equation delta t times A average equals delta v. And now we can plug in the numbers and we get our delta v. You plug in your delta t, you plug in your A, and delta v would be the answer. All right, and the units of this would be, since it's a velocity, a change in velocity, it's meters per second, because velocity is measured in meters per second. And the third choice, number 3, that would be what would the third choice be? It would be, you're given, let's say you're given delta v, and you're given A, solve for t. All right, so in this case, all right, t is your unknown, so you're going to have to do the algebra that will allow you to solve for delta t. So delta t times A average equals delta v, but we don't want to find delta v, so we have to do more to get delta t by itself. And we'll divide by the average acceleration. So A divided by A cancels, and you get delta t equals delta v over A average. All right, and now from here, the delta t is your unknown. That the units for the delta t, seconds. And plug in delta v, change in velocity. plug in A average acceleration, and you're done. Alright, so that is the math in the, I'd say, least confusing way, because you don't have to worry about numbers right now. You don't have to worry about units right now. You're just worrying about the symbols. And once you plug in the numbers that have the units, then you deal with them after. So why don't I give you some examples? And if you don't like this method, I have another method for you that maybe you'll like better. And I'll show that while I'm showing everything else. So, examples. So, a car speeds up from rest to 30 meters per second in 10 seconds. What is the car's acceleration? Alright, for this one. So first of all, when you're actually interpreting these problems, it's best to draw this out. So if a car is speeding up, you need a before and you need an after. So if it speeds up from rest, that means the V initial equals 0. That means the V final is 30 meters per second. Alright, and if it started at 0 and it ended at 30, we actually can say our delta V is 30 meters per second. The time it took, so it started here and it ended here, the time it took to do that was 10 seconds. And what we want to know is the car's acceleration. If you draw them out, if you focus on the question and understanding the situation enough to draw them out, there's a pretty good chance that either you're going to get it right or you're going to know exactly what you don't understand, and you'll be able to get help and get your problem solved. One of the hardest things in physics is figuring out what it is that you actually don't know. That's actually a very difficult thing to do. So from here, we have our equation. The average acceleration is delta V over delta T, and we just plug in number 30 meters per second divided by 10 seconds. And notice how I wrote my units. I did not write them diagonal. I wrote them vertical because that helps. If you write them up and down like this is going to help you be more organized and not make mistakes with the units. So next we see 30 divided by 10 is 3, and then we deal with the letters. We've got meters per second per second. What do we do with that? Well, this is the thing that is a pain that we don't really want. So we're going to multiply by top and bottom by 1 over seconds. And then if we see S is on top and bottom, and this whole bottom part ends up going away, it becomes 1. And then we're left with the top. We've got the 3, meters times 1 is meters, seconds times second is second squared. So our average acceleration is 3 meters per second squared. Alright, let's try another one. A car slows down at a rate of -2 meters per second squared. In 20 seconds. How much did this car slow down? Alright, So for this problem, you got a car slowing down. So we actually don't know. What we don't know is, we don't know its initial velocity. We don't know its final velocity. We do know that it decelerates or it accelerates in the negative direction at 2 meters per second squared. And we know that it takes 20 seconds. So the challenging part here is, what does it mean by how much did this car slow down? And if we look through the acceleration equation, we see that we're given a delta t, we're given an a, so would that make sense that delta v is could tell us how much it slowed down? And yeah, delta v is a drop or a change in velocity. So if you want to know how much it slowed down, you want to know how much that velocity dropped. So we are going to do it two ways. Version 1 will be what I showed you before. A average equals delta v over delta t. And we want to find the delta v, so I'm going to multiply both sides by delta t. And so we got delta t times A average equals delta v. And now I'll plug in the numbers. 20 seconds times, and this is 2 meters per second squared to the left, so that is a negative 2 meters per second squared. Okay, and so s squared cancels with the s, and we're left with negative 40 meters per second. And that is how much velocity we lost. Version 2. Alright, version 2, it starts here just like the other one, except with version 2 we plug in the numbers right away. And I really don't care which way you use. You would use whichever way seems easier to you. So we'll have negative 2 meters per second squared equals delta v divided by 20 seconds. So now I'm going to multiply top and bottom by 20 seconds. And then they cancel from that side. And we're left with seconds cancels with the squared in seconds squared. And we're left with negative 40 meters per second. And so what you notice here is that in both cases, the answer is negative 40 meters per second. And that's how we know that it's each way is the same. It doesn't matter how you do it. Third possibility. All right. I guess we'll call it letter C. Okay. A car goes from 0 to 60 meters per second in at a rate of 1 meter per second squared. How long did this take? All right, so here's our situation, and so we have a car. It goes from 0, the initial is 0, to 60. V final is 60 meters per second. Its acceleration is actually positive 1 meter per second squared. And then its t is unknown. Alright, so two methods. A equals delta V over delta T, and I multiply delta T by both sides. Alright, but it's not done. Delta T is not isolated, so I have to divide by A on both sides. So the A's cancel here, and I get delta T equals delta V over A average. And now I can plug in numbers. Delta V, it goes from 0 to 60. So technically a delta V is V final minus V initial. So we get 60 meters per second minus 0 meters per second, which is just 60 meters per second. Alright, and then we have divided by acceleration, which is 1 meter per second squared. Oh, and the units will be a pain here. So 60 divided by 1 is 60 meters per second divided by meters per second squared. Alright, now we have to simplify these because this whole bottom half, I mean, we don't like it. We like things to be simpler. So let's make it simpler. Seconds squared divided by meters, top and bottom. That's what I'm going to do. Multiply top and bottom by seconds squared over meters. Because that gets rid of this whole bottom set of I guess fraction signs or division signs. So when we're looking at this, we see that there's a seconds here and a second squared here. So one of the seconds will cancel from each, and then each of the meters cancel. So we are left with 60 seconds. That's it. And that makes sense because we're looking for time. And if you've done these right, you will get seconds every time. You know, if you've done the simplifications right, you will always get seconds for time. Time has to be in seconds. It can't be in anything else unless it's like minutes or hours. But you can't have seconds in meters. You can't have seconds in hours squared per centimeter. I mean, it's got to be time. All right, so that's part C, and now I'll give you some practice problems. Alright, for these practice problems, I didn't say it in it yet though, but what I expect from you is 1, a diagram, 2, show algebra. Oh, I think I forgot to do method 2 on the last one. Shoot. I'll do that in a second. 2. Okay, there's one of each. And now I'll give you one that's a little bit trickier. It's a little bit like 3, but you'll see. So, alright, so there's 4, and I'll give you one more easier one just for a little extra practice, I think. So, not super easy, but okay, and for the last one on the other page, I don't think I wrote the number 2 spot. Let's see if I even remember the numbers. Oh, I don't. But basically, version 2 just says plug in numbers first, then do algebra. Version 1 says do algebra first, then plug in numbers. Either way is fine. If this ends up being a problem for you that I didn't do that one, just let me know as soon as you can, and I'll try and help further. Alright, that's it. Good luck. Hope this helps.